This is a story about time. So integral to our lives, we carried with us everywhere. In our homes, in our pockets, on our bodies. When we count down on New Year's Eve or submit our homework at exactly 11:59 p.m., 23 seconds before the deadline, we don't question the time. It just is. But who decided that? Who got to decide that here in Waterville, Maine, it's 11:52 a.m., which is 13 hours behind my home country of the Philippines? And speaking of being from the Philippines,
How is this 5 p.m.?
and why is the day divided into 24 hours? What does time even have to do with my GPS? Are clocks a mass conspiracy built to control the public in a game that quantifies human worth by one's productivity, defined by how much capital they make a corporation, thus devaluing those who cannot be as efficient as the status quo? Is time even real? Looking at the history of time may give us some answer to these questions. Now, this story is quite literally a tale as old as time, but for our purposes, we can still learn a lot by focusing on a small slice. But first, we'll need to do a little bit of traveling back in time. Whoa, wait. Too far. Gotta fast forward a bit. Yeah, we got the oldest civilizations using the sun and the seasons to keep time. Then the Egyptians started using sundials, dividing into 12 marks. Then for overcast days and nights, they used water clocks with 12 marks too. In East Asia, time started being measured by candles and incense clocks. And then Catholic monks developed mechanical clocks for prayer and worship. And then pendulum clocks are developed by Christian Huygens and Galileo Galilei. Then that became more portable through pocket watches first developed by Peter Heinlein. And then, there we are. This brings us to the Royal Society of the 17th century. Established at the cusp of the Enlightenment, the Society is a scientific academy that focuses on experimental and empirical evidence rather than solely depending on logic and rationalism. Now, their methods are succinctly summarized in their motto, Nullius in verba, or take nobody's word for it. The Royal Society was where science as we know it had first formed its foundations. We can recognize many scientists, or natural philosophers as they were known in the 17th century, who were elected as fellows of the Society, including Isaac Newton, Michael Faraday, Charles Darwin, and Ernest Rutherford. But don't let this list of genius scientists fool you into thinking that the Society was operating in complete isolation from the politics of the time. It seems that we often study science this way, noting Newton's invention of calculus, but not quite explaining its centuries-long development from Greece to China to India, or learning about Darwin's theory of evolution, but not about how academics in the 1800s used social Darwinism to justify racism and imperialism. The Royal Society was established in London, a city that did not yet have a university, in an attempt to be at the empire's heart of commerce and trade rather than scholarship. This made clear the perception of science as a social, political activity. It was only in the 19th century that science became much of a paying gig. So in the 1700s, despite the society encouraging more scientific debate and collaboration, science was really only a gentleman's hobby, often limited to those who were already independently rich. Still, because being a scientist wasn't really a salary profession at this time, that meant that the line between amateurs and professionals wasn't really clear-cut. It's this ambiguity that was one of the reasons for the passing of the Longitude Act of 1714. This act established a board of longitude and offered a prize to anyone that could develop a method for solving the longitude. After all, the bill is general and not confined to any one project, person, or method, but gives equal hopes to all judicious proposers whatsoever. The act was supported by many people and institutions of power, including those of Navy officials, merchants, and even Newton himself. But what was so important about the longitude problem anyway? For sailors, latitude was easy to calculate. Because latitude was how far north or south one was, all one needed was to compare the angle of the sun or the North Star to the horizon line. The longitude, however, was a lot harder. Because the sun and stars continuously moved from east to west, longitude was much more difficult to pin down. Britain had its fair share of losses due to this problem. But what it stood to gain was perhaps even more desirable. As Sir Walter Raleigh wrote, "For whosoever commands the sea commands the trade. Whosoever commands the trade of the world commands the riches of the world, and consequently, the world itself." So, how did people go about solving the longitude problem? Isaac Newton had some ideas, but he admitted that these several projects were true in theory, but difficult to execute. He had mentioned four. One involved the eclipses of Jupiter's satellites, another by the place of the moon, and another being a proposal by Humphrey Dillon that involved firing rockets at fixed times in known locations. However, it's the fourth proposal that brings us back to the point of this story. Newton writes of a watch to keep time exactly. By knowing the exact time at a specific point in the world, say Greenwich, England, one only needed to compare the time at their location via the sun to the time in Greenwich to find the longitude. However, at this point in time, the best mechanical clocks were operated with pendulums. Pocket watches were a thing as well, but it had served more as a status symbol than an accurate timekeeping tool. Those who owned clocks of any kind would have to regularly reset their time to some master clock. And while there were already inaccuracies on land, the rocking of a ship and its variation of temperature would only serve to make a sailor's clock even more unreliable. Despite these difficulties, a chronometer that was reliable enough to be used in ships would eventually be developed by John Harrison, a man of no formal education beyond his family's trade of carpentry. His proposed H1 used two interconnected swinging balances that allowed it to reliably record time, even on a moving ship. After passing trials, Harrison was awarded £250 in 1737 to build an improved clock. While he had worked on H2 for 2 years and H3 for nearly 2 decades, Harrison radically changed his plans to develop H4. Now, remember when I said that pocket watches were more of a status symbol than an accurate timekeeping device? It was Harrison's H4 that challenged that perception. While bigger than a pocket watch, it was much more portable than his previous chronometers, but it was even more accurate. Against the master clock, it had only gained 54 seconds in 156 days. In terms of error and distance, H4 had calculated an error of only 38.4 seconds, equivalent to 10 miles of longitude on the equator in 7 weeks. While clocks began to become more and more accurate and more accessible, the Industrial Revolution had begun to rapidly change the empire. And in between trains, trade, and telegraphs throughout England and the world, standardized time became more important than ever. In 1884, the International Meridian Conference in Washington, D.C. had officially set the prime meridian at the Royal Observatory in Greenwich, England. It was the Industrial Revolution that set the stage for a modern view of time as a commodity that is meant to be used. It wasn't only time that began to be standardized, but money too. And it was only a matter of time that the line between the two started to blur. After all, we save time, waste time, budget time. Our work is strictly plotted against the clock. We're paid hourly, with each hour valued at a specific sum of money. It's here the pressure to work as much as possible is felt, because any time spent not working means one has less money and therefore less ability to live. As clocks became more accessible to individuals, employers began to use them to discipline their employees. To be paid, workers had to clock in and clock out at a specific time. A worker's time was no longer their own. It belonged to the employer. Within the capitalist system, wages and time being measured with labor became a preventative measure against idleness. E.P. Thompson writes, "In mature capitalist society, all time must be consumed, marketed, and put to use. It is offensive for the labor force merely to pass the time." In a society so enveloped by time, it would seem wrong to claim that time isn't real. And yet it seems in science that's exactly what it says. Einstein's theory of relativity shows us this. There is no such thing as a fixed interval of time independent of the system to which it is referred. There is indeed no such thing as simultaneity. There is no such thing as now independent of a system of reference. Simply put, we experience time differently. In physics, this is much more obvious when dealing with objects traveling near the speed of light, but the math checks out regardless. There is no such thing as universal time. And for a concept that isn't quite absolute or objective as we think it is, we somehow worship time like a god anyway. Barbara Adam writes, "If contemporary physicists can embrace temporality and relativity and reflexivity, why then is it proving so difficult to find public approval for such an approach in the social sciences?" One might want to ask. This is a story about time. Real or not, it's a framework that has embedded itself in our lives that it's impossible to truly escape. But it is a worthwhile exercise to look at something that we often deem unquestionable and try to question it anyway. In the story, we've seen accounts of people making mistakes and solving problems and improving upon each other. In other words, being human. In a world that sees technology as a neutral tool, that sees science as an arbiter of the objective truth, it's important to take a moment to question what might be behind these curtains that we didn't even know were there.